First, welcome to my YouTube channel, Mathematics Medicine. So in today's video, we are going to evaluate this integral. So find the closed form of integral from 0 to pi over 2 of the theta over a minus b sine square theta. For a is greater than a minus b, greater than 0. Hence, we are asked to evaluate integral from 0 to pi over 2, the theta over 9 minus 5 sine square theta. Alright guys, so let's dive into the solution. Please, if you are new to this channel, don't forget to subscribe to my channel, like my videos, comment, and share. Okay, solution. So, solving this integral, that is finding a closed form for that integral. So, we have integral from 0 to pi over 2, the theta over a minus b sine square theta. So this is what we are going to do. We are going to make a substitution. Okay, so let t be equal to tan theta. So if t is equal to tan theta, what will be sine square theta? So you can draw a right angle triangle. So where this place is theta, so that shows this is the opposite and this is the hypotenuse and this is the adjacent. And don't forget that tan theta is equal to opposite over adjacent. So where the opposite is t and the adjacent will be 1, so t over 1, it means t. So what will be the hypotenuse? So hypotenuse will be opposite square plus adjacent square, or the adjacent square plus opposite square. That is 1 plus t raised to the power of 2. That is the hypotenuse. Now let's find sine theta. So don't forget that sine theta is equal to opposite over hypotenuse. Okay, that is sine theta will be equal to opposite, which is t, then over the hypotenuse, which is square root of 1 plus t square. Okay, so that is sine theta. So now let's find sine square theta. So if you square both sides, we are going to have sine square theta equal t raised to the power of 2, then over. So if we take the square root of 1 plus t square, we are going to have 1 plus t square. Okay, so that is sine square theta. So since we have sine square theta, which is equal to t square over 1 plus t square, so that is sine square theta. Now let's differentiate this. We have t equals tan theta, so let's differentiate that. So since t is equal to tan theta, so if we differentiate t with respect to t, so we have the t equals, and if we differentiate tan theta with respect to theta, so that is sec square theta, the theta. And then remember that sec square theta is equal to 1 plus tan square theta, okay? And then where tan theta is what? T. So we are going to have the t is equal to 1 plus t raised to the power of 2, the theta, okay? So that is the t. And then you can make the theta the subject of the formula here. So the theta will be equal to the t over 1 plus t squared. So that is beautiful, guys. And then the limit is also going to change, Before, the limit is theta is from 0 to pi over 2. So now let's find when t equal theta. So what will be the limit? So when t is equal to 0, so t will be equal to tan 0, and tan 0 will give us 0. Okay, and then when t is equal to pi over 2, when theta is pi over 2, so we have t is equal to tan pi over 2, so which is going to give us infinity. Okay, so the limit for t is now from 0 to infinity. Okay, so now let's write the integral. So we are going to have integral from 0 to infinity. So the theta is now the t over 1 plus t squared, and then we have a minus b multiplied by sine square theta. So sine square theta, we say it's t square over 1 plus t square. So the theta is the t, then over 1 plus t square. Okay, so and then so that is this. So that will be 1 over integral from 0 to infinity a minus b t squared 1 plus t squared. So we are going to multiply through by 1 plus t squared. So if we do that, we are going to have integral from 0 to infinity of 1 over, so a will multiply 1 plus t squared, so that will be a into 1 plus t squared, then minus b multiplied by t squared, because 1 plus t squared 1 over 1 plus t squared multiplied by 1 plus t squared, that will give us 1. So we have the theta. So that is the next thing we have now. So I want to evaluate this integral. integral from 0 to infinity of 1 over a. You can open the bracket. So a times 1 is a, plus a times t square will give us at square, then minus bt square, the t. So which is also equal to integral from 0 to infinity of 1, then over. So a plus, so what do you notice here? T square is common, so that will be plus a minus b multiplied by t square, then the t. Now, let's write this out and solve that integral. So what you have now is integral from 0 to infinity of 1 over a plus a minus b multiplied by t square, the t. So I can assume that alpha is equal to a and then beta is equal to a minus b. So alpha is a and beta is a minus b. So if I do that, I'm going to have integral from 0 to infinity of 1 over alpha plus beta multiplied by t square, the t. So which is also equal to integral from 0 to infinity of 1 over, so I can factor out alpha in the denominator, that is alpha into 1 plus beta over alpha multiplied by t square, the t. So taking out 1 over alpha, so we have 1 over alpha integral from 0 to infinity of 1 over 1 plus beta over alpha t square, the t. Okay, so which is also equal to 1 over alpha integral from 0 to infinity of 1 over 1 plus, square root of beta over alpha raised to the power of 2 is still the same thing as beta over alpha, then multiplied by t square, the t, which is equal to 1 over alpha multiplied by integral from 0 to infinity of 1 over 1 plus. So we can bring square root of beta over alpha and t together. That is square root of beta over alpha multiplied by t, then everything raised to the power of 2 dt. So the next thing we are going to do here is to make a substitution. So making a substitution, I'm going to put x to be equal to t multiplied by square root of beta over alpha. So that is the x is equal to the t multiplied by square root of beta over alpha. Okay, then we're going to have, the limit is not going to change. Okay, so we put infinity to be t, so it still will be infinity. We put infinity to be 0, to be 0. Okay, so what you have now is 1 over alpha multiplied by integral from 0 to infinity of 1 over 1 plus. So instead of writing t multiplied by beta over alpha, so we are going to write x raised to the power of 2 and dt. So this is dx equal dt square root of beta over alpha. So if you divide both sides by this, we are going to have dt is equal to square root of square root of alpha over beta dx. So dt is now square root of alpha over beta dx. Okay, so that is a dt. So you can bring out this constant. So we bring out the constant. Okay, let me clean the upper part so that we can have some space to work. So we're almost done. So what we have now, so if I bring out this constant, I'm going to have 1 over alpha multiplied by square root of alpha over beta, then multiplied by integral from 0 to infinity of 1 over 1 plus x raised to the power of 2 dx. I already explained how to integrate this kind of integral in my videos, so I will paste the link in the description. Okay, so this will be 1 over alpha multiplied by square root of alpha over beta, then multiplied by arctan of x, then from 0 to infinity. So then if you apply the limit, we are going to have 1 over alpha multiplied by square root of alpha over beta multiplied by, so arctan of infinity will give us pi over 2 and arctan of 0 is 0. Okay, so now let's simplify this completely. Now 1 over alpha multiplied by square root of alpha over square root of beta. So if you multiply both the numerator and the denominator by square root of alpha, so I'm going to have 1 over alpha multiplied by square root of alpha, then multiplied by square root of alpha, then square root of alpha, then over square root of beta. So square root of alpha then square root of alpha will give us alpha. So we have alpha over alpha multiplied by square root of alpha multiplied by square root of beta. So what you have now is alpha, we cancel out alpha. So what you have now is 1 over square root of alpha multiplied by square root of beta. So which is equal to 1 over square root of alpha multiplied by beta. And don't forget that it's multiplying pi over 2. So multiply by pi over 2. So the original value of alpha is a and beta is a minus b. Okay, so this will be equal to 1 over square root of, so alpha, which is a, and beta, which is a minus b, then multiply by pi over 2. So we can write this as pi then over 2 multiplied by square root of a into a minus b. So that is beautiful. That is beautiful. So that shows that, so that is integral from 0 to pi over 2 of the theta over a minus b sine square theta is equal to pi over 2 multiplied by square root of a into a minus b. Okay, so for a greater than a minus b and greater than 0. So the integral we are asked to solve, which is integral from 0 to pi over 2 of the theta over 9 minus 5 sine square theta. So in this case, a is equal to 9 and b is equal to 5. So just substitute into this formula we just derived. Okay, so that will be pi then over 2 multiplied by square root of, so a, which is 9, into a minus b, that is 9 minus 5, so which is equal to pi then over 2, so multiply by square root of 9 multiply by, so 9 minus 5 will give us 4, which is square root of 4. So this is equal to pi over 2 multiplied by square root of 9 will give us 3, square root of 4 will give us 2. So we have pi over 2 times 3 is 6 times 2, 12. So you have pi over 12. So that shows that this integral right here is equal to pi over 12. So that is the answer. Alright guys, so don't forget to subscribe to my channel, like my video, comment and share. See you next time. Yeah, thanks for watching.